So suppose I take an example of an energy level of minus 1 electron volt, and it gets split in, say, minus 1.4. Then is the topmost energy level of the band. Then I assure you that it will be minus 0.6 electron volt, so that the average still remains minus 1 electron volt. Now, dear students, if the valence electron, because in a atom the outermost electrons are defined as valence electrons. If the energy levels corresponding to these valence electrons are splitted and forming a band, then it is called valence energy band. And the top energy level of the band is called EV, valence energy. These are field states, and if these electrons of the valence band are capable to obtain some energy and they can become free, then those free electrons are said to be lie in the conduction band. This is conduction band, bottom level of the conduction band. The difference between the bottom of conduction band and top of valence band is called band gap, energy band gap. This is a very simple model of the band theory, but at this MSc level we have to work more, we have to understand it more. And remember, to determine these energy levels and energy bands, energy levels of the energy band, we have to solve the Schrodinger equation for the electrons which are moving in the solid. And we all know that Schrodinger equation requires a good knowledge of the potential of the electron in which they are moving. Dear students, here in this class we shall consider a special type of potential, that is periodic potential. I will tell you about this periodic potential in the upcoming days, and in that periodic potential we shall assume that the wave function of the electron also satisfies a particular condition that was given by Bloch, and the theorem which was given by Bloch is called Bloch theorem. We shall start this with this. Here it is. This is the Bloch theorem. See, it states, the statement of Bloch theorem is, it states that any solution of Schrodinger equation for an electron moving in one-dimensional periodic potential. Periodic potential means the value of the potential is repeating itself after a certain distance. So in one-dimensional periodic potential is a modulated plane wave of the form, that is the value of the function psi, that is the solution of the Schrodinger equation, psi at any position x. Suppose we are considering the movement and the potential, one-dimensional potential, to be along x-axis. So according to this theorem, psi x must be equal to ukx e to the power iota kx, the plane wave solutions. Then this uk satisfies this periodicity, mean the value of x is equal to value at x plus a. Again, if you say it will be the same value will be occurring at uk at x plus 2a, x plus 3a, and so on. So the periodicity of this uk is at an interval of a. Here the potential has a periodicity of a also, because Vx is defined equal to Vx plus a. So not only the potential is periodic at an interval of a, the function uk which is appearing in the wave function of the Schrodinger equation, the plane wave solution, is also a periodic. So this is what Bloch theorem is. And the Schrodinger equation, we all know, it is double differentiation of the wave function psi with respect to position plus 2m upon h cross square. We all are familiar. What is h cross here? H cross is h upon 2 pi. You are well familiar. And this is E, the total energy of the moving electron, and V is the potential energy or potential energy of the electron. Now we all know that if V becomes 0, this becomes Schrodinger equation for a free particle. But if V is not 0, it is a Schrodinger equation for a bound particle. The function described by this equation 1 is called Bloch function. So in examination, if you are asked to define Bloch function, then you should say that solutions of Schrodinger equation in a periodic potentials are given by this, and these are called Bloch functions. And you can see psi at x plus a, you just replace this x by x plus a, I will get psi x plus a is equal to uk. This x will convert into x plus a, e to the power iota k. Again x will be written as x plus a. Now there is simple mathematics, we all know uk x plus a can be written using this. See, uk x plus a is ukx, I have written it, and e to the power plus minus iota k x plus a can be divided in two parts. It can be written as a product of these two functions, e to the power plus minus iota kx and e to the power plus minus iota ka. And dear students, this is psi x, so I can say psi x plus a is equal to psi x into this quantity has been written as q. This is called Bloch function, and q is e to the power plus minus iota ka. Okay, now this equation number 2 shows the Bloch theorem in other sense. We can use this equation 2 in the way to prove this Bloch theorem. So in examination you can give the statement of Bloch theorem like this, and then we shall try to prove it in a mathematical way, that psi x plus a is equal to q psi x. This is what we have to prove. And Schrodinger equation is a different equation, differential equation of order 2. I hope you are familiar with order of any differential equation, and there is a double differentiation of the wave function psi. That's why the differential of equation of order 2. So it has two independent solutions, and let me assume these two solutions to be fx and gx of this particular Schrodinger equation, and we shall solve it on the next page.